Okay, one second. Sorry. What did I recently have open up? This one? Yeah, that's good enough. Okay. Okay. Awesome. Cool. Alright, let me make sure everything's working. Alright, awesome. Okay, so this is another programming stream. So in the last programming stream that I did, we went over variables basically. So just a quick review of last stream. When it comes to data types and when it comes to variables, Java has a few data types for integers. It has byte, short, int, and long. They don't really matter for beginners. The main one that you want to go for is int. So out of those four, you always, I would say 95% of the time, 99% of the time, you're always going to declare the data type as an int for any integers. The difference is how it's stored in memory. So this can store less in memory, and long stores the most. So it reserves the most space in memory. That's the difference. Usually we don't really care about that. Most of the time we don't care about that. We're just going to assume that, memory is bountiful. So I would just suggest always go with int. Then there's other data types like float and double for any decimals. I suggest always going with double. If you do go with float, you have to add that F on the end. Very important. And then the other data types are char, which is a single character, which is single quotes. String, which is a sequence of characters, double quotes. And then Boolean. So those are the 5 big ones. So you have integers, use int. You have decimals, use double. You have char for single characters. You have string for a sequence of characters. Char is single quotes. String is double quotes. That's the syntax for it. So be sure to do that. And then Boolean is true or false. So you always say true or you always say false. Anything else, you get an error. So those are the big 5. Int, float, double, char, string, and Boolean. Cool. So then there's vocabulary words that you should know. So there's addition and concatenation, right? So concatenation means that you are appending one string to another string. So for an example, if I say this space oh gosh, my typing today is some spaces to it. Okay. So here's my string. This is a bird. So this is concatenation. In Java, when you have several strings and you use a plus sign, that's called concatenation. You're appending one string to another string. So this part right here will be appended to this space right here. And then this space right here will be appended to is appended to the space, then the space is appended to a, so on and so forth, right? So that's concatenation. It's just appending a string to another string, and they append on each other on the very end. So for an example, if I print it out in Java, which is just something that you know, you type it so many times, you just know it. I wish I was on my Mac. Okay. Oh, I'm like, okay, am I too big? Let me do something real quick. So webcam, Brio webcam, there it is. I'm just gonna copy that, paste. Make me a little smaller. All right, cool. I think you can guys see that. All right, sorry. And then my contacts are messing up, so I can't read. All right, so let's make sure everything looks legit. Okay, so this is concatenation. I'm printing out this message. Let's comment this out. So that's something else in Java. The comment out code, you do // for single lines. So that's what I did. I commented out that code. Now the only thing that should print looks like to be this statement right here. So in Java, in the first lesson, I said that you have to compile the code. So you use javac, which is the Java compiler. Which let me see how to explain this. So basically, we take our code that we're writing and we have to make it understandable by the computer. So we have to put it, eventually it has to go to machine language, which is, you know, binary. So what the compiler does, it changes the code that we write into Java bytecode, and then Java bytecode is ran by the Java virtual machine, and it turns it to, you know, to binary, so the computer, or so your computer can understand it. So that's just basically what we're doing. We're just compiling into another, you know, code so the computer can understand it. So javac, and then of course that happens. I don't think that's it. Yeah, so I'm not in the right document. So clear. We got a cd into documents. Say dir, there's demo, great. So then javac. Of course. Comment that out, because that's not right syntax. Okay, so it compiled, great. Now we call Java main to run the code. Boom, this is bird, this is a bird, print it out. All right, one more time. Java main, this is bird, print it out. So that's concatenation, right? Concatenation is just taking strings, appended them to each other. Great. So then it just comes into, you know, what if you try to do this string plus a number? What happens? A string plus a number. Will it add it together or will it append it? So that's the question. Compile it, run it. So the answer is it appended it. Why did it append it? So we took a string, letter 6, that's the variable. Letter 6 contains the string 6. How do we know it's a string? Because we declared the string data type and it's in double quotes. That's how we know it's a string. That's the syntax. So that is how we declare a string in Java. That's what syntax is. It's just the rules on how to, you know, perform some action. So for integers, we declare int, and then we do no quotes at all, just a number. So this is an integer and this is a string. That's the difference between these different 6s. So why did it print out 66 instead of adding it together? Well, it concatenated. In the end, it concatenated. So it did coercion. That's another buzzword. So it just basically converted this number 6 into a string. Yo, Sage of 6 pass. So it converted. So when you add an integer to a string, it'll change the integer to a string, and then it'll do concatenation that I was talking about earlier. So this is turned into a string when adding it to another string, because that's just how it works in the background. It coerces this number into a string. So this integer becomes a string, and then when you do a plus sign on two strings, it's called concatenation. It just appends it to the end, so it doesn't add them together. So this ends up being 66 because it did concatenation in the end. Great stuff. So that's important to know. So whenever you're adding any type of string, an integer in a string in a string, it does concatenation. But when you add a number in a number, it does addition. So that's important to know. So if I do number 6 and I do plus number 6, it should do addition because number 6 is an integer and number 6 again is an integer. So I should get 12. Boom. So 12. Great. So that's just addition. So whenever you add up integers with another integer or decimals with another decimal, you'll either get a decimal or you'll get an integer. Yep, but if you add an integer with a string, it does concatenation, so it just appends it. It converts it all to strings and does concatenation. If you do a decimal in a string, it's going to change the decimal into a string and does concatenation again, so it just appends it to it. And the end result becomes a string. That's just what happens in the background. That's what happens in the background, just coercion. Good stuff, good stuff, good stuff. So in this case, when you add an integer and a decimal, so in this case, when I added this integer, number 6, with a decimal, which is 293.39393, the end result was a decimal. So what happened was coercion again. When you add an integer and a decimal, the end result becomes a decimal. In this case, double. You didn't notice I streamed yesterday? Yes, I did. I did stream quickly yesterday. It was just briefly streamed Pokemon Unite. It was very short. But yeah, so just to recap, if you do addition on an integer and integer, the result is an integer. If you do integer plus a decimal, the result is a double. I keep saying decimal, but when I mean decimal, I mean the double data type. So integer and a double, it becomes a double. When you do a double plus a double, it becomes, the end result is a double. If you do addition on an integer and a string, the end result is a string because it does concatenation. And lastly, if you do addition with a decimal and a string, the end result is also a string because it converts it and does concatenation. So those are pretty much the big ones. So that's good stuff there. And that's just the basic of variables. For variables, the syntax, very important, is the data type first, followed by the variable name. Variable name can be anything that you make up: pizza, bird, dog, animal, is bird, number 5, whatever. And then you assign it a value. So the syntax for the value, depending on what the type is, if it's an integer, no quotes at all. If it's a character, you use single quotes to assign the variable. If it's a string, you use double quotes. If it's a float, you add the F on the end. Good stuff. Did you ever make a bot that did your math homework for you? That would be funny. I'm actually pretty good at math. I'm like I can do a lot of math in my head. Well, not too complex, but I was always good at math, so I didn't really need. But that would be cool. Just a bot that just does stuff. Just does stuff for me. But yep. So that's very important. Data type first. Excuse me. Data type first, followed by variable name equals the value. So that's the syntax. That's all you have to know. In other programming languages, so this is a vocab lesson time. So this is a strongly typed programming language, which means that you have to declare the data type first. Strongly typed programming language. In other programming languages, loosely typed, which means that you don't have to declare the data type at all. So this is like PHP, this is Python, this is JavaScript. So those are loosely typed programming language where you do not have to declare the data type. The programming language or the parser or whatever the engine is, I don't know what it is in some cases, but they figure out what the data type is for you, just behind the scenes. But in Java, which is a strongly typed programming language, you have to explicitly state the data type. So that is good stuff there. Yep, so that's just the basics of variables. I mean, if you get, this is the foundation right here. If you can get, if you can get what data types are, and these are also called primitives, which are just, every programming language has different primitives, which means that they have built-in data types that some guy, some girl made up. They just made it up. They just made up some data type, and they tend to all be the same, but somebody just made up some data types which they call primitive. They just made them up. So in this case, they made up some data types called byte, short, int, long, float, double, char, string, boolean. In other programming language, there's like, who cares? We're gonna make our own data types. We're gonna call it A, B, C, and D, and they do that. It's just whatever they want. So that's what primitives are. There are built-in they're built-in data types. So this is a great transition into what I'm going to talk about next. So these built-in data types are great, right? But sometimes you want to programmers can also create their own data types. Now it gets complicated, because these are built-in data types that, you know, the developers created, like the creators of Java. I don't know who created Java, but we'll just say Oracle. We'll just say Oracle. Wait 1 second. Sorry. Yeah. Alright, so we'll just say Oracle created Java, even though I don't know. So we'll say they created, you know, these data types, and to be fully flexible, we want developers to create their own data types to be 100% flexible. So now we get into objects and classes. So there's technical definitions of what classes and objects are. I'm just going to use my own definition. I'm going to tell you that they're basically their own data types. They're developer created data types, user created data types. So that's data types that me and you create. That's what classes are, and that's pretty true. Honestly, that's how I would describe it. So let's get into it. I'm gonna take a look at the Java doc, so I can just stay 100% on it. Did I pause this? Okay, cool. Okay, so classes. So, okay, this is, oh gosh, this is a can of worms. Oh goodness. Okay. Okay, so you create a class by declaring the keyword. So in programming languages, there are these things called keywords, which they do a certain thing in the language, right? So you can't use these for any other reason but for their intended purpose. So class is a keyword, so you can only use the keyword class when you're creating a new class. So in this case, they're creating a class called bicycle. Great, fine, okay, that makes sense. So next up, what is within what does a class contain? What are the features and the benefits, and, you know, the properties of a class? What is a class? So the first thing about a class is that it contains fields, right? So in this case, they're creating a class called bicycle. So this is the syntax, right? You declare the keyword class first, and then you do the class name. In this case, the class name is bicycle. And then you follow it with an open curly brace and a closing curly brace. Can you see that? Do I need to blow that up? Yeah, probably. Yeah, that's much better. Okay, I blew it up. Okay, cool. Okay, let me repeat that one more time. So you got to declare the keyword class, followed by the class name, an open curly brace, and then down here a closing curly brace. It's so important that you I hate, let me repeat myself. I hate looking at somebody's code and it's not formatted. And what I mean formatted is that whenever you do an open curly brace, anything inside of it needs to be indented. So this space here, like this space is indented, this space is indented, this space is indented. The reason why it's indented is so it just looks better and you can read it cleanly, so you know what to expect. So this is another curly brace here, and another closing curly brace, and everything within it is also indented. So it's just a tab. Now it's so funny because us programmers, there's this thing where there's a debate whether this should be tabs or this should be spaces. The indentation, should it be spaces or should it be tabs? I'm all for tabs. I hate spaces. You should never use spaces for indentation. Never, ever, ever. So that's my position on it. Okay. So if you want to be a good programmer, always format your code. Never have ugly code, ever, ever. Okay, so back to classes. Keyword class, class name, open and close curly brace. Syntax, you just gotta know it. Next you have your fields. So fields are basically properties on the class. So this is what you can think of classes as, they say, it's such a redundant thing that people say, but it's like the blueprint of an object, and we'll get into what an object is. But they're basically properties, what things have. That's what fields are, what things have. Fields and properties are interchangeable. So you'll hear me saying fields, you'll also hear me saying properties. I like to say properties because it just makes more sense to me. Fields are just I'm like, what the heck is a field? Properties is probably a more accurate word. So that's what I'll probably be using, honestly. So what are the characteristics of a bicycle? What are the properties of a bicycle? Well, a bicycle has gears, which is here. I can't even pronounce that word because I'm screwed up. And it has speed, right? So that's the properties of the bike. So that's what a bike has. Like, I'm a human, I have a hand. That would be a property inside this class. If we change this, if we created a class called person or human, we can create one right now. We create a class called human, right? Then we can create properties or fields. Oh man, did I screw that up? Let me see, I'm sorry. Actually, I don't think you can do that, sorry. I'm thinking, I know, I'm mixing up programming languages, but alright, so public, the syntax is, I don't think you might not need that. Let me double check. Yeah, I don't think you need public. I mean, public is good. We'll go over what public is later, but I don't think you need it. So, isn't tabs easier? Tabs is easier for sure. Tabs is easier for sure. Like spaces, like spaces. No, spaces like spaces are error prone. That's my argument for it, and it's just ugly to see. Yeah, tabs are easier. You're right, 100%. Yeah, so we'll go over what public is later. You don't need it until we discuss what public is, but for now, don't worry about it. So you can actually do just class name, data type, and then the variable name. So these are the properties. So the class is a human. The properties, I'm gonna say hands, and then I'm gonna also say legs. So those are properties. There's other properties too that you can just make up. I don't know, ears, can speak. I mean, all kinds of properties. So class is like creating something from scratch or something else. Yes, it's very much like that. Objects are anything that you make up, basically. Just like the data types that we're talking about. Anything that you would like to make up, that's what you would make a class. It's basically, that's what I was saying earlier, like, it's developer created data types. The developer creates it. Just whatever you want. It can be anything. And that's why it's so powerful, because you can make it anything, you can make it do anything, you can make it have any properties. So that's great. So that's what properties are. They just what things have. We'll go over constructor in a second, but next I would like to go over methods, right? So methods are what things do. So properties or fields are what things have, and then methods are what things do. So in our case right here, in this human class I made, we're gonna say you always, so whenever you create a property or a field, you always declare the data type first, and then when you create a method, you also declare the data type. In this case, we're going to go over like methods in a second, but we're going to say void. So void means that it returns nothing. So we'll go over what returning is in a second. But we're going to say a human runs. Cool. I mean, that's easy. We're going to say a human walks. Now we just create methods. It's just that easy. So this is the syntax. You do the return type. So the return type in this case is void. That means it returns nothing. You do the method name followed by an open and closed parentheses, and then you have your open and closed curly brace. So that's the syntax. That's the basics right there. Okay, now it gets a little complicated. It gets a little complicated, right? So my human, I'm gonna say my human does math. Oh gosh, this is gonna be fun right here. So my human does math, and it returns an int, right? I'm clearly doing something wrong here. Oh yeah, okay, cool. I'm doing everything right then. Okay, awesome. Okay. Alright, so this is great, right? So can you give a dog the ability to sing like Beyonce? You can totally give a dog the ability to sing like Beyonce. I mean, Beyonce, you know, Ariana Grande, Kelly Clarkson. I mean, you can make the dog do anything. But yeah, so what we just went over, so classes have fields and properties, or fields / properties, because they're interchangeable, and they also have methods. Properties are what things have, and then methods are what things do. So the important thing to note here is that you first declare what the method returns. In this case, the human runs, so that's what it does. So in this case, this method returns nothing. I'm gonna say it returns nothing. It just does stuff. It just returns nothing. The human walks, it doesn't return anything, this method right here. But this method right here that does math, it returns an integer, because I declared that this method returns an integer by saying int does math. And then inside return is a keyword, it returns the number 1. So let's look at a little example right now. So this is the variable stuff. Let's comment this code out really quick. Comment out that code. Oh man, wow, this is gonna be some interesting stuff, man. It's gonna get complicated real quick. Alrighty. Like, bear with me. I'm not a Java developer, so I might make a few mistakes. So just bear with me. Um, yeah. So we just talked about classes, right? And we're gonna go more in depth with classes in a second. But what I just did, I created an object. What the heck is an object? So we have classes, right? Classes are basically the blueprints of our object. So we define what objects are with classes, kinda. Let's see if I can try to make sense out of this, right? So this is the blueprint, right? This is the blueprint of what a human has. A human has hands, has legs, it runs, walks, and does math, right? So an object, we say an object is an instance of a class. So that's just, buzzwords there. An object is an instance of a class, which just basically means that we take the blueprint and we actually make a human. That's what an object is. We take the blueprints from a class and we make an actual human. Yep. So in this case, the class is called humans. So we created our own data type. That's what an object is, in my opinion, at least. That's how I define it. We created our own data type, call it human, and then we're gonna name it. We're gonna name it Josh. That's my name, right? So we created a variable called Josh. So this is the syntax. We do our data type, we do our variable name, and then here's another keyword, right? New is a keyword. This is how you create a new object. You always say new, and then you do the object name followed by an open and close parenthesis. There's a lot to take in, right? So we declare the data type, we declare the variable name, and then we assign it a value, which is the new keyword, followed by the class name, followed by the open and close parentheses. So now we just created a Josh object of type human. Very important. Okay, good stuff. Oh, I had a follow. See, I don't know what's going on with my volume these days. But thanks, Desfritos, for the follow. Plus, I can't read because my contacts are adding up. But yes, I'm trying to make sense out of this the best I can. So, alright. Knox, yes, you're back. I'm glad to see you. You just got out of your class. Great. Yeah, you're gonna have to watch this a couple of times, man. This is hard to understand. This is hard for me to explain, honestly. This is really hard. But yeah, Knox, welcome. I'm just going over objects and classes, and this is like the hardest, most difficult thing to grasp. But once you understand it, man, this is great stuff. Like, you can take over the world. Okay, let me just recap over everything again, just to be sure. So earlier, I was talking about data types, right? This is just what the original programmers in the programming language came up with. They came up with these data types. And they were like, oh, wouldn't it be cool if, programmers could create their own data types? What? And that's what happened. That's what objects are, basically, where us programmers create our own data types. So double is a data type. that have decimals. Well, we can create our own data types. And in this case, I created a data type called human. So when I say data types, I'm talking about classes. Classes are blueprints, right? They define what our objects will be. Objects, so this is buzzword time. So objects are instances of classes. Meaning we're actually making these. We are making these things in memory. That's what an object. When we create an object, we're actually creating we're actually creating something in memory that resembles the class. So this object that I created called Josh resembles this human blueprint that I defined. We were going over objects and classes as well. Woo! That's great. Our book had good analogy. Classes are the cookie cutter and the object is the cookie. Yes. Yes, that's exactly it. That is exactly it. The cookie cutter. Yes, that's exactly it. It basically just says how the object is supposed to act. It defines how the object is supposed to, like, the properties of the object. It's just basically the blueprint, the outline, the cookie cutter. It's just a guide, basically. Basically, it's the DNA, right? Like, your DNA tells you exactly what your hair color is, your skin color, how tall are you, how tall are you gonna be, all that other stuff. So that's basically what the class is. It's just the blueprint. So in this case, I created a Josh object. So we're gonna start doing some stuff now. We're gonna do some stuff that's interesting. So I created the Josh object, right? I can create another object. So what did I just do right there? I created another object in memory called Bob. Bob can do the same thing Josh can do. Bob has hands. Bob has legs. Bob can run. Bob can walk. And Bob can do math. Great. So can Josh. So now let's do some stuff. Let's see. Oh gosh, this has been a minute since I've used like Java, so we're gonna see if I know what I'm doing. Alright. How specific do you need to be? I need a little bit more information about that one. I don't know how to answer that question. I need a little bit more information. Okay, so here's the interesting part, right? So last thing I said is that method, so when you define a method inside your class, the method returns something or it returns nothing. So void means it returns nothing. In this case, where it says does math, we say it returns an integer, right? So let me do, actually I want to print line. So what happens here is Josh is the object. Now here's another buzzword. I'm gonna invoke, which means I'm gonna run this method called does math. So Josh is my object of type human. Human has a method called does math. So Josh is going to invoke the does math method. This is the syntax. You take an object, dot does math, open and close curly brace, or open and close parentheses, sorry. Right? So what should happen is Josh does math runs, and then it should return 1. So this entire line right here, everything that I highlighted, should become the number 1. It should return 1, basically. So what happens is this becomes 1, and then the system prints out 1. That's what should happen. Hopefully that happens. Or I'm gonna be a liar. Oh my goodness, I'm telling the truth. It printed out 1. Great. Okay, how specific do you need to be when creating the object? You can make it as complicated or as simple as you want it to be. That's the great thing about classes and objects. Because you define it. You're defining the object. You're defining the class. It's basically the data type that programmers create. So you can make it whatever you want. So that's a great thing. So that's great. Cool. It does math, returns. So it returns an int. In this case, it returns 1. Let's just change it up. I want to return 100. Cool. I'm gonna compile it. Let me clean that up a little bit so you guys can see. I'm gonna compile it. Boom. I don't know if you can see that. Let me like blow it up a little bit. Let me see. I don't know. Good old VS Code, man. I never actually zoomed in my entire life on VS Code. Alright, let me just try this out. This is probably gonna work. What do you know, man? Hotkeys are amazing. Hotkeys are gold, man. Hotkeys are gold. What I did Control plus. When you're a really good developer, you just know your hotkeys, and I just knew my hotkeys. Okay, cool. So we're just gonna drop that down just a little bit. Okay, so good stuff, good stuff. So yeah, does math, returns 100. So when I invoke the method, does math becomes 100, and then it prints it out. Great, awesome. So if Josh can do math, can Bob do math? So I compile it, I run it, Bob does math. He also returned 100. Man, this is good stuff, good stuff, good stuff. So now we're getting somewhere. We're getting somewhere. It's getting interesting. It's getting interesting. It's getting very interesting. Let's do some more fun stuff. Let me see if I can do some even more fun stuff. Man, it's been a minute since I've done some stuff. Alright. Okay. So that was a method, right? So a method syntax is the dot, followed by the method name, which is does math, followed by an open and close parentheses. That's the syntax. So what about properties? What's the syntax for properties? Let's see. It's the same thing, kinda, without the parentheses. So it's, in this case, Bob dot hands. Does that sound good? So you just, anytime you want to access, buzzword again, anytime you want to access properties or methods, you always use the object followed by the dot, and then depending on if it's a property, no parentheses, and if it's a property, you use parentheses. Just like that. Cool. So now we're going to see what this prints out, right? So Bob hands, so it should print out too, because Bob has hands, and hands is defined as the property, which is equal to 2. Let's see what it does. What it do? So we compile it and then we run it. Oh, it printed out too. Great. So now we know what classes are. We know what an object is. We know it has properties, which is what it has, and then we know it has method, which what objects do. Let's get more complicated. Let's get complicated with this. Okay. Let's see. Let's get a little bit more complicated. Oh gosh. Okay, so we're gonna get a little more complicated. So we're gonna say the human can now add. We're gonna say the human adds number 1 and then number 2. Oh goodness, I'm doing some fun stuff here. Boom. Alright. This tab 9, I think it's called. Man, it's doing some stuff. Alright. Alright, wait. Oh gosh, this is... I figured that was a problem. Yep, that was a problem. Okay, cool. Oh gosh, this is fun. Oh yeah, it gets even more complicated. Let me try this. It gets even more complicated. Okay. So what I just did was, these are so these are called parameters. So any method in any function, that is, return means. So what returns means? So return means, so when I go back to this one, okay, so what return means is, well, this is what I define return is. There's probably a more technical, way to say this, but when you run this method, so when we invoke, that's the buzzword, when we invoke this method, it's being called, the method is being run at line 67, right? So the line is being ran at 67, right? So what happens internally is more or less, it hops to line 86 and it says return the number 100. So then it hops back to line 67 internally, and then it changes this line. It returns, that's kind of where it comes from, I suppose, because when this method is ran, hops to line 86, returns 100, so it hops back or returns back to line 67 and changes this to 100, basically, internally. That's basically what return means, because it hops to here and it returns a number, which then the number replaces the method that was invoked, basically. I always forget to add the data type. Yes, it's so easy to forget. So easy to forget. Okay, so back to this method right here. So I added a new method called add, and these are called parameters. So now we're getting into the nitty-gritty. So these are called parameters, and what parameters are is something that you pass into methods and functions. So in this case, when you do addition or add, when you call the add method, it's saying that you need to pass in two numbers, pass in num1 and pass in num2. and then it's going to take num1 and it's going to add it to num2 and it's going to return it. One second. Thought someone was at my door. Okay, so return is like retrieval from memory. Wouldn't quite say that. It's basically what we want our invoke method to give back to the program. That's kind of what I would say it is. We want what was invoked at line 67 to return a value so our program can use that. We know the does math returns some value. We want it to get a value for us so we can use it. I guess that's kind of how I would put it. Is that a stretch? Yeah, that's the way I would say it. I would say that we know the does math has a value and we want that value from the method. So it returns it to us. It returns it to that program, to line 67. It returns it to us and then we can use it for whatever reason. But now back to this add method with the parameters num1, num2, right? Good stuff, good stuff. So it takes num1, num2, these are the parameters. The syntax for it is the data type needs to be first, followed by the variable name, and then any additional parameters need a comma. Okay, so now let's take a little look at that one. So Bob can add, right? So we want Bob to add 1, and then we want to have Bob add the number 2. All right, so Bob will be adding 1 and 2. So what happens is now, this is important to note that these are called parameters. So a method has parameters, and then you pass arguments, which are actual values, so you pass in arguments here, and then these are parameters. So that's the difference. The difference is that parameters are on the method, whereas arguments are actual values passed to the method. So those are kind of the keywords there. That parameters are defined on the method, whereas arguments are passed to the method. So we're passing the number 1 and passing the number 2 to this add method. So then num1 becomes replaced with the number 1, and then num2 becomes replaced with the number 2 in this instance. So then it should return the number 1 plus 2, which equals 3. So it should return 3. And then this is replaced with 3, and then it's going to print out 3. Oh man, that is some stuff. Okay. See, print out 3. Man, that's some tough stuff, I'm telling you. Okay. Oof, 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 oof. So parameters, good stuff. Params. And then you have a return. Why you type main in the terminal? So my class is named main, and my file is named main. That's why. My file is named main. That's why I do it. So with Java, you have to compile the file. My file is named main.java. So you do Java C main.java to compile it. And then to run it, you say Java main. So I'm just basically saying run my file. That's why. Because I named it main.java. Yeah, if this file was named something else, like if it was named teacup, then I would change this to teacup.java, and then I run Java teacup. But the file isn't named that, so. Good stuff, good stuff. Okay. So earlier I said that, some methods return things and others just do things. They don't return anything. In this case, we're gonna have run just print something out. It doesn't return anything, it just prints something out. So now when I call josh.run, the run method is invoked, meaning that on line 67, it's going to jump to line 77, and then it's going to run this line of code. It's not going to return anything because void means it's just going to do something. So run is just going to do something, and it's going to print out this message. And print out I ran them out. Cool. So I hope that makes a little bit of sense there. We have properties. That's what things have. We have methods, what things do. So in this case, when you call the run method, it's going to print out something. That's what it does. It's not going to return anything, it just does something. And I want it to print out something. Another example of what you can do with the void method, you can have it, you can have it create a file on your system. Another thing that you can do, you can have it compress an image. That's what a void method would be used for. It just does something, it doesn't return anything. And so in this case, an example of a method that returns something, in this case, this one does math, right? So this one returns 100. So this 100 needs to be used by the program somewhere. So it returns this value to whatever it called it, to wherever it was called from. That's what return basically does. This line, when this line is executed, it returns this value to wherever it was invoked. So the program can continue to use this value. Yeah, that was a great explanation. Oh, thanks. Wow. Because this is like really hard to, like, this is like one of the core things. Yeah, so when I do add again, so I'm just gonna bring it home. If I want to do 500,000, if I want to add 500,000 with 34,742, if I want to do that kind of math, right? When this line is invoked, it's going to jump to, because this is the add method, when this line is invoked, it's going to jump to line 90. Num1 is what I passed in as an argument, which is 500,000. So num1 becomes 500,000. Num2 becomes 34,742, right? Because that's what I pass in as argument 1 and argument 2. In this case, since it's on the method, this is parameter 1, parameter 2. And then it's going to take those two numbers and it's going to add it together, and then it's going to return it to line 68 so the program can use it. So the program can continue to use it. So I'm going to do something interesting here. Alright, so I did something interesting, right? So normally I was just printing it out. I was printing out what the method had returned. Well, we don't typically do that in programming. We usually store it in a variable. So Bob just added these two values together, and then when this method was invoked, it returned the addition of these two values. So 500,000 plus 34,742 will be returned. So this line becomes the addition of that, and then we're going to store it to Bob added value. If that makes sense. So could a bot solve a complicated math problem with the person programming it doesn't know how to solve it? Yes, that happens all the time. that's basically yeah, you just describe operating systems and programs in general. That's what programming is all about. Programs allow people to do stuff without knowing how the program works. Complicated stuff. See, I don't know how to do, like, we don't know how to do complicated math, but a calculator does. So you can